Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on reservoir simulation using tNavigator software. Okay, so it's a very useful and interesting reservoir simulation software, and hopefully we can learn something from this series of videos. Okay, we will have several videos from this series, and it's about setting a new well, a new producer, or a new injector, and hopefully also a new horizontal well into this reservoir model. Okay, so currently we are looking at our reservoir model. This is model from tNavigator tutorial. Okay, so yeah, we can use this software. We can use this tutorial to learn something that is very important. Okay, so we are currently looking at the two-dimensional pressure map. And as you can see, from two-dimensional perspective, the pressure is homogeneous. The pressure is uniform across the reservoir. And this is the three-dimensional view. Okay. But if you want to drill wells, if you want to drill new well, we most of the time we will look at the saturation. Okay. Yeah, of course, we will also look at the pressure, but in this situation where the pressure is uniform, we should look at the saturation of oil if we want to drill oil well, of course. Okay, so this is the three-dimensional saturation of oil map, and you can see the color gradation. Highest saturation will be colored red, and the lowest will be colored blue. And as you can see, our time step, looking at this time slider, still at the November 2008. Okay, but even more practical than looking at the saturation of oil, we can also look at the mobile oil in place. So if you minimize the calculation or calculated tree and go to fluid in place and select mobile oil in place, okay? So this is the mobile oil in place map in 3D view, okay? Saturation of oil is good and practical. We can use that to plan our drilling location. But even more practical than that, if we can look at the mobile oil in place, because at the end of the day, the oil that we produce comes from the mobile oil in place. Not only oil in place, because some of the oil in the total oil in place will be immobile. We want to get the oil, and we can only get the oil from mobile in place zone. Okay, but instead of looking at 3D view, we start with 2D view. And from 2D perspective, we can look at this. This is the rooftop view. If you open this drop-down menu, you can look per layer, layer 1 in IJ perspective, layer 2, layer 6, and so on and so forth. But we can also look at this sum. So it's the total mobile oil in place, okay, being observed from above, from our point of view. This is min, max, average, and so on and so forth. We want to drill vertical well, so we prefer looking at sum. I want to drill my well, my new well, in area whose sum of mobile oil in place is the highest, right? Whose sum of the mobile oil in place is the highest. So we can target, we can locate our new well, maybe in this area, okay? And we will set our new well there. To help us to determine the spot, we can tick these grid lines. Okay, so you can see the grid lines. All right. And then we can zoom by scrolling using our mouse. Okay. So let's say I want to place my new well here. I can press Alt and left click. So that's the way we do in tNavigator. Once again, I press Alt button and then left key. Okay. And then you can also do that by right click and add well. Okay, the same. Okay, so now we get this new window for adding new well. The first one is geometry. And geometry, we start with this one, surface head position. So it will be located at X33, Y26. Okay, regardless of the Z layer. Later on, Z layer here, you can look at Z layers here. But from XY perspective, X is 33, Y 26. That's for geometry and connections. You can also use trajectory, but we will use trajectory later when we drill horizontal well. And then direction, vertical well. We want to drill vertical well for now, but if you want to drill horizontal well, you use deviated. Okay. All right. So now here, ID. So it's ID 1, 2 through 11. Okay, by default, it will be opened. Okay, all the Z layers will be opened. And this is the X location, Y location, and Z locations. Z layer 1, layer 2, through layer 11. Okay, and then directional. The direction will be, yeah, vertical. So it's based on Z direction. And then transmissibility factor 0 by default. Okay, no change in transmissibility. Productivity index 1. Okay, so it will rely on the permeability, existing permeability within the model, the thickness, all right? Well diameter 0.16 in meter, skin 0, okay? No formation damage, but of course you can decrease your skin if you are quite sure that the formation is stimulated, or if it is damaged, skin positive. And this is the date scheduled, the time step at which you drill your well. So we drill our well from the beginning, okay? But you can also add maybe 2 years later, 3 years later, based on your time selection. You can easily do that by moving this time slider. By the way, you can also select to shut some layers like this, shut. So practically speaking, in the real world, you do not perforate all the layers. Okay, that's what it means. So open, shut, open, shut, open, shut, open, shut. Okay, so rather than perforating all the thickness of this vertical section, you, you chose to perforate only some sections of it. Okay, so that's for geometry. And then we go to, by the way, you can also rename the well. So let me name the well producer 1, P1, and then we go to the control. Okay, you can set the control. By default, the first will be control mode based on bottom hole pressure and 50 bars. Okay, I will use this value. So the first layer of control will be bottom hole pressure. 50 bar, but you can also add second layer of control. In this case, I want to use liquid rate maximum to be 100. Okay, so the first gate will be bottom hole pressure. So the model will give me 50 bars, and then the model will try to give me also 100, but cannot be more than that. Okay. You can also set drawdown. Maybe you have maximum drawdown that is allowable to avoid, for example, send control issue, send production issue, right? You can also set the minimum drawdown if you want to get sufficient production rate. You can use that. Let's say I don't want to use drawdown here. By the way, this is what we do in graphical user interface. Behind the scene, there is text editor. That is sort of code. So if you, for example, if you tick drawdown, there will be keyword added in our text editor, okay, in our code. And in tNavigator, the keyword will be well draw if you select to activate drawdown. But hopefully we will have another video regarding text editor, script editor, or the coding. So this series of video it's just about graphical user interface. Okay, and then you can also set the economic limit. In this case, I want to make well efficiency factor 0.9. Nothing is perfect, right? And then economic limit, and also the work over the activity that you will do if this limit are exceeded, are reached. For example, I will do, well, this one, if I reach maximum water cut of 0.3 or maybe 0.4. So if my water cut is 40%, if water cut of 40% is reached in this producer, then I will do this activity. I will shut the well in. I will shut in the well based on this selection. I can also do nothing. I can also shut in the worst offending perforation. All right. And then I can also shut in the worst offending perforation and below. So it's very, very useful, right? But in this case, I will select shut in the well itself. Okay. If the water cut of 50% or 0.4 is reached, then I will shut in my well. Okay. So I think everything has been selected. We can add well. So this is our well. All right, so the name is P_1, and the production rate will be controlled by BHP, bottom hole pressure. Here, show wells, show well names. You can also show well status. Okay. So that's our well, and in 3D view, you can look at our well there. Okay. You can also select transparent. So you see our well with the connections there. That sort of ball is the open perforation. So we do not perforate all the sections, right? There. So it's open, shut, open, shut, open, shut, something like that. So it's this ball looking feature, it's perforation. Framework only. Okay. Grid lines. All right, so everything has been set up. We can run. So the run calculation, first I will show you the map view, and later on I will show you the graphs. So you see the saturation or mobile in place are changing because we produce oil, right? So the mobile in place are changing. I mean the palette is changing, the values in the palette. All right. So now there is no more red area surrounding our well because we produce the well. We produce the oil, there is no more red area showing high mobile oil in place. Like if we go back to the original time step, you see we have red area indicating high mobile oil in place, but we produce and this red area will disappear as we produce the oil from using the well. You see, right? So the mobile in place is changing. And of course, that's for saturation as well. Saturation will change, especially surrounding the well. You know, it's now become yellowish, even greenish, right? That's also the thing that you can look at in the 3D window. You know, now it even becomes blue, showing low oil saturation because we produced the oil. All right. And now let's go to the graph. So you understand? Now we go to blue, right? Showing low, relatively speaking, low oil saturation. Yeah. And then we go to the graphs. Okay. First, I will untick everything. I will explain it to you. Okay. First, in graphs, we show you the rates and then open the well. You only have one well, which is this one. And untick everything first. First one is oil rate. Okay, oil rate. So yeah, you have this oil rate. If you open this one, there will be oil rate, oil mass rate, oil rate with VFAC, oil rate with gas lift. No, we only need just oil rate. So this is the oil rate. So as we said before, the maximum liquid rate allowable, the second control is 100. Okay, standard meter cube per day. But yeah, you know, we maintain that we can achieve 100, but it cannot be higher than that. And as the production continues, now the liquid rate decreases, especially actually it's like oil rate, liquid rate, oil rate. We can also show the water rate. So currently within these years of production, there is no water. So in this case, liquid rate equals oil rate because there is no water. You see, at the latest period of time, the production decreases. No water so far, but in the second video, I will put a new injector and we will see what will happen to this producer. Of course, water cut will increase quite fast, because of the new injector that I will put. So this is for the rate. We can also show the total. Again, untick everything first. Oil total, and then water total. No water, of course, so far. And then the fluid in place. Okay. Current oil in place, of course, oil in place will decrease as we produce the oil. And pressure. Pressure is also very important. The first one I want to show you is pressure on equivalent radius. So it's like static or average bottom hole pressure or average reservoir pressure, I mean. Okay, average reservoir pressure. All right. You can also select field. So it's the real average reservoir pressure. Okay, it's the real reservoir pressure. It is just sort of pressure on equivalent radius, average pressure surrounding the well. And this one for bottom hole flowing pressure. Okay. So if you go to, again, groups, we have field. This is showing the reservoir, the field itself. Average pressure, yeah, it's just average reservoir pressure. There is no other definition. Okay. And then if you go from the field to the well, now it's well level. And in well level, we have pressure on equivalent radius. So it's like average pressure surrounding the well, not from the entire reservoir. And then the bottom hole flowing pressure. You can also show the bottom hole pressure input limit. We set it to be 50, right? So it's the value 50, the limit that we impose. So yeah, we can produce at pressure higher than 50. 50 is the minimum to enable flow. All right, so yep, this is for the first case. In the next case, I will add a new injector. Also, it's still also a vertical well. So it's a vertical injector. We will drill new injector maybe 2 years after this well, the production well is on stream. 2 years from that, we will add new injector, and let's see what will happen to the oil rate and the pressure. Okay, so that's all. I hope you enjoyed the video. I hope this video is useful. Thank you so much for watching, and see you again in the next tNavigator videos. Thank you.